So this model, which has been around for a number of years, start from the top. This is a model containing some beam elements, not really part of the evaluation. Otherwise, it's a solid model. In this case, a lot of these solids are thin sheet metal. So looking at the mesh settings, I've used a lot of sweep method, solid shell. So selecting these thin parts, defining them as automatic thin will give you a good mix of being able to have quite large element and don't have to care about the thickness of the plate because it's a shell formulation. Other parts like flanges, I use ordinary solid elements and just used sweep method. So setting this up, a number of, what else do we have here? We have the bottom frame part, which again also use some sweep and hex meshing, multi-zone, so it's a mix of things. We see some preparation here for the fatigue evaluation, so adding some biasing, so I will be able to use hotspot. What I've also included in this model is some geometry preparation for be able to defining welds. So specifically, I want to add fillet welds between these parts. And as we see, I have prepared a split face. So there is an edge that I can select and create fillet welds at. Going on, we have in this big model a number of connection folders, so grouping different features in different folders, and in the end doing a contact status. So this reveals all my contacts. So as we see, I use a lot of bonded contacts between parts, and this can then be used in weld evaluation. It also makes meshing easier when you have contacts instead of multi-body parts. So it's a good practice to check out this contact tool before solving. Next up, to work on defining all bolts and welds, there are a big number of name selections, and using the worksheet method, you can then easily select and identify features. So in this case, I've used select by size and location to identify the bolt head and bolt nut holes. Actually, in the 2024 R2 Weld Toolkit, there is a new option that you simply can select the face and the bolt hole size, and the app will identify the holes for you. So that's a nice addition. But for welds here, we kind of need to predefine what locations we have welds. So here are the edges, as we see, gusset edge and gusset face, the reference face for defining these welds. Moving on, this model contains a few boundary conditions at the base here. We have a set of loads, gravity. We have a fluid load is inside the silo, and we have the wind load. And this is again nice with a solid shell, how we have the outside where we apply a wind load in different directions. And we might have a snow load, and as said, we have the fluid load on the inside, and can use contacts between the parts. So then comes, in this case, we have a set of bolts. So not talking about that specifically, but coming here to my weld definition. So in this case, I have two groups, one group for fillet weld and one group for butt welds. So my fillet weld group is defining here, as we see, tube to plate, the gusset to tube. So we have as we see here, the plate to tube, and we have all the cross member welds. And finally, a virtual fillet weld between the L flange and the cylinder walls. So since the size is quite huge, zooming in here, again, we see how it visualizes the weld in the same way as this add weld. So we have the weld toes visible, and we have somewhere at the start of the weld also the throat section and the kind of face. So we see a clear visualization of the weld size. And in a similar way, you can do butt welds, and they are simply visualized based on the reference face and down through the thickness. So we can see that the size matches the geometry. So talking about butt weld here, here is the standard single-sided, but now we see here we also have double-sided and double-sided intermittent. So then you simply define the size of one part of the welding, so from each side. So these virtual welds also, it's possible to modify them even if after the model is solved, and that's one nice feature. So you can actually change this to a double-sided weld and re-evaluate the result. Or you can, as always, add the weld result as a result feature only. But as we see, this is quite a huge model, and displaying all welds might be a bit heavy. So I can always toggle the display welds off, so then model just displays as out. I can always click on each object and see the details, but it's possible here, as we see, to directly toggle off or the ID numbering for each section. Right, so now that we have defined the loads, the welds, we can do the solving, and in this case we have a number of load steps, and typically we can look at the maximum over time or the time of maximum. So what load case is the most critical one? And if we toggle to result file items, we would also, if we zoom in, see the actual weld elements that are added. So next up are the different weld results. So when I now have this group of fillet welds, I could then add fillet weld strength, and I get then a weld result for each of these weld features. And just as with mechanical results, I can then evaluate the maximum over time. And then as a final feature, I can group them together. So this grouping feature is a nice trick. So select here, group weld strength. I can drag this into a group and simply click here, and it will then load the items in the group. And another thing here is the ability to select from what analysis you want to group results. So I'll come back to this in a little second. So I delete this for now, but a grouped result then will let you evaluate all these result objects in one common plot. So here we have one picture showing maximum over time weld utilization for all welds in the, as we see here in the bottom framework. Next up is the weld fatigue feature. So as mentioned here, I was using hotspot, and you can then, when you set this up, if I clear this result to demonstrate, and then we turn on the mesh, it visualizes my weld because I selected the same scoping as for the weld and defining this as to include this weld to offset. So by saying that this is a 5mm weld, it visualizes and displays now my extrapolation lines. So it doesn't need to be a perfect fit, but it will interpolate from the existing nodes. So if you have a mid nodes, this green line would be matching those nodes quite well. And if you wouldn't get a result from hotspot, it's simply because you have two coarse mesh, so there is nothing to extrapolate from. In this case, I've defined a load combination, meaning a check between the kind of unloaded state and, in this case, wind load set direction. So I can then evaluate, and it would show me, in this case, the damage, the stress range, or safety factor, or what result item I choose. So in this case, I'm displaying here the damage per block. So this load case is set to be 100,000 cycles. And directly we see here that damage is 4, and that is way above a limit. Going on, we can define more load cases and add a cumulative damage. So the cumulative damage here looks for this hotspot for different loading blocks and calculates the total damage. So here we see then a total damage of 5, or a safety factor of 0.19. So only 90% of the expected life. Going on, you can define more fatigue result at different portions, and just as with weld strength, we can create a grouped cumulative damage. So we can again simply bring together two different cumulative damage results to display them at once in one single picture. So in this case, these plates and one at the gusset here. And finally, a different grouping here for studying the strength of the fillet and butt welds of the cylinder, and again a grouped result. So again, we can see combine both butt weld and fillet welds in this grouped result and look at the utilization. So this is my base analysis. Then comes new conditions. So I've added what's called an extreme operation. So basically duplicating this analysis and modifying the loads for some extreme weather condition or something else. So to reuse the same bolt and weld setup, I use what's called the child setup. So I from the bolt and weld toolkit toolbar, I add this, and I can only add it once. So this will then directly display and use the defined bolts from the selected target analysis, parent analysis, and same goes with welds. So I don't need to copy paste, and this will of course then be a big value, because if you decide to change the parent weld items, this child analysis will directly have those new changes, and you can then resolve it, so you don't need to edit in multiple places. And you can then easily do like this, add parent result. So to demonstrate again, I can simply add a new analysis. So going home, add a new static structural. I want to simply drag and drop the boundary conditions to this new analysis. I click on the child setup, and I can now select my parent analysis, and it only shows where I have weld features, and this is in from this analysis, and I want to do the same with the bolts. So quickly selecting here. So now this model is set up in exactly the same way, and will be, if I change the bolts and welds in the first analysis, the linked analysis will have the same settings directly. And I can now, with a click of a button, import all the weld results from this parent analysis. So and we get here directly grouped in the same way, linked to this analysis. All the settings are now the same. But I can also, if I want, do like this, add weld strength results. So in this case, all the defined welds are created from this one. And the same goes with bolt setup. Here I can add bolt strength or bolt fatigue as results directly linked. So very fast to set up the model, and again, by using this virtual weld definition, we have much better control when post-processing the model. Rounding this off, so after solving this extreme operation, I have a set of new results for this one, and I can then do use what's in mechanical called a solution combination. So here I can, as we see, select a number of environments and a number of steps. So here I defined all 6 load steps from each of these 2 analyses, and I can evaluate and say, give me the maximum over all steps. So in the definition, I say envelope. I don't do load case operation, but this is then a maximum over all defined load steps. And I can do the same now in both Bolt and Weld Toolkit with this grouped strength results. So looking on the bolt grouped result, so again, you pick it from the menu here, and you have the option for rivets, bolts, and bolts fatigue. And in Weld Toolkit, it's for grouped weld strength or grouped weld fatigue. So a grouped weld strength result, I can then select the analysis, and I select the result from that analysis. So here we have then for each of the weld groups, one from each analysis, building up this table, and the ability now to do a maximum over time or minimum over time for that sake, or I can also choose whether I want to look at if plotting, combining results to look at the minimum, like safety factor or maximum utilization, or use the standard. So you can look at the different specific time point, like load step 4, and take the maximum value or the minimum safety factor, or as shown here, the maximum over time. And with fatigue, of course, looking at what is the worst case cumulative damage from these ones. So that kind of brings me to the end of this demo on how you can utilize the best Mechanical's workflow in terms of solution combination, maximum over time, and also how the toolkits now can be used in this in a similar fashion to automate and get your results very efficiently.